Hi, Anna and I are here today to show you how to get a perfect hole in Cornhole by using physics. But first we're going to explain the rules and show you guys a quick game.
This game can be played with 2 or 4 players. With 2 players, they will both stand on either side of one of the cornhole boards. And with 4 players, 2 people will be at each board with 1 teammate at each board, diagonal from one another. These boards will be 27 feet apart from one front of the board to the other.
The goal of the game is to get 21 points before the other team does, but if you go over 21, your team is sent back to 15. You can collect your points by throwing your bags onto the opposing board to get 1 point, or in the hole for 3. If your opponent gets a bag onto the board or in the hole along with yours, they will cancel out. Now it's time to play some cornhole. We only played to 11 here due to the length of the game, and whenever the bag would roll from the ground onto the board, we wouldn't count that point due to the bag touching the ground before hitting the board. After that great game, it's now time to see if we can find the physics behind getting those perfect hole-in-ones. We're going to be using some kinematics equations, including the equation final position equals the initial position plus the initial velocity times time plus 1/2 times acceleration times time squared. We're going to find the initial velocity of the bag that we would need to throw it at. If we assume the angle to which we throw the bag, the accelerations in both the x and y directions, and the distance we would throw it would stay constant.
We would first find time in terms of the initial velocity in the x direction. If we manipulate the equation Claire stated above, we get time equals the final position minus the initial position over the sine of the initial velocity. If we consider that the acceleration in this direction would be 0. We would plug this in for the time in the equation for the y direction and would solve for the initial velocity if we use 9.8 meters over seconds squared for the acceleration in this direction.
After we find that time equals x final minus x initial, or distance, over velocity initial in the x direction, we are able to find the initial velocity in both the y and x directions. There is a velocity in both of these directions because I am not throwing it either upward or horizontal with the ground. So to be able to find the perfect hole, we would have to be able to find the initial velocity that we need in both the y and x directions, considering all the other elements that we listed beforehand stay constant.
So after plugging in the expression for time, we can begin to substitute the y direction of the initial velocity to the sine of theta times the initial velocity, and the x direction of the initial velocity to the cosine of theta times the initial velocity. After we cancel some terms out, move some terms in order to get velocity initial by itself, and simplifying sine over cosine to the tangent of theta, we get that velocity initial equals the acceleration in the y direction, which is equal to 9.8 meters per second squared. Like we pointed out earlier, times the final position in the x direction squared minus the final position in the x direction times the initial position in the x direction plus the initial position in the x direction squared. all over 2 times the final position minus the initial position in the y direction, minus the final position minus the initial position in the x direction times the sine of theta.
Thanks for watching!